Hello friends, in this video I am bringing first law of thermodynamics for you. In this video I'll tell you what kind of questions are asked from first law of thermodynamics and how can we attempt these questions. So let's start. So first of all, you must remember the statement of first law of thermodynamics. This law states that energy can neither be created nor destroyed, although it may be converted from one form to another form. It can also be stated in other ways. Second one, total energy of the universe remains constant. Third one, total energy of an isolated system is constant. So you must remember that in first law of thermodynamics, the energy can neither be created nor destroyed, and energy can be converted from one form to another form, and the total energy of the universe remains constant. And in isolated system energy is constant. So one question can be asked from these statements. Then we have second concept, or its mathematical expression. The mathematical expression for first law of thermodynamics is delta U is equals to Q plus W, where delta U is change in internal energy, where Q is heat absorbed and W is work done on the system. And this expression changes to Q minus W. Delta U is equals to Q minus W when work is done by the system. So you must remember that when work is done on the system, then the expression is Q plus W. When work is done by the system, then the expression becomes Q minus W, and Q is heat absorbed. Okay, so one question can be asked from these expressions. Now let's move to important results. So the important results are: number one, delta U is equals to Q plus W, as we know from the expression of first law of thermodynamics. From this expression we deduce that delta U is equals to QV. So this expression can be asked that which one is correct. So this expression is deduced from the expression that W is equals to minus P external delta V. This is pressure volume work, I told you in previous video. And at constant volume, when the volume is constant, that is delta V is equals to 0. That means V1 is equals to V2. When both are same, then delta V becomes 0. V2 minus V1 becomes 0. And when delta V becomes 0, W becomes 0. No work is done. Okay. When no work is done, this becomes 0. Delta U becomes Q. So at constant volume, the change in internal energy is equals to heat absorbed. So you have to remember that internal energy change is heat absorbed at constant volume. This is very important. At constant volume, heat absorbed is equals to change in internal energy. So this is the first result from first law of thermodynamics. Then we have second, that is for isothermal reversible expansion or compression from V1 to V2. This is also very important. So you must remember, when the word isothermal is used, isothermal means the temperature remains constant. When the temperature remains constant, no energy leaves or enters the system. That means total internal energy becomes constant. U1 is equals to U2. It means delta U is equals to 0. Okay. So for isothermal, delta U is equals to 0. We are also talking about reversible expansion and compression. So delta U becomes 0, then the expression becomes 0 is equals to Q plus W. On rearranging, Q becomes minus W. On bringing W from right side to left side, sign changes. This becomes minus W. As I told you in previous video, you have to remember this expression, that Q is equals to minus W from here, and minus W is equals to 2.303 nRT log V2 over V1. So question can be asked that for isothermal reversible expansion or compression from V1 to V2, which one is a correct option? So delta U is equals to 0, and also Q is equals to minus W, and Q is equals to minus W is equals to 2.303 nRT log V2 over V1. So you have to remember this one, and this one. Then we have third important result. Isothermal expansion of an ideal gas into vacuum. We are using isothermal. Delta U is equals to 0. You have to remember this one, that when we are using isothermal, delta U is equals to 0. And now we are also using the term vacuum. When we are talking about vacuum, external pressure is 0. When external pressure is 0, work done is 0. No work is done. W is equals to 0. When W is 0, Q also becomes 0. So when we are talking about isothermal expansion of an ideal gas into vacuum, then all the terms, that is delta U, W and Q, they are equal to 0. So you must remember, question can be asked that which is correct for isothermal expansion of an ideal gas into vacuum. You have to check the options. Okay, then we have last important result, that is adiabatic change. As I told you that adiabatic change is the change in which no heat enters or leaves the system, that is Q is equals to 0. Now Q is equals to 0, it means delta U is equals to W adiabatic. Okay, this is the last important result. The question can be asked from this expression.